back, and now we want to start discussing Lesson 14, Other Planetary Systems, the New Science of Distant Worlds. So this is going to be Chapter 10 out of your textbook. So I want you to be able to tell me, why is it hard to see a planet? So there's two reasons. One is because of diffraction effects, makes it look blurry. And two, it's just so close to its parent star that the parent star gives off too much light and then you can't see it. All right, now how are we going to measure the time it takes for a planet to go around its star? And so the first method is by using a transit. So this is called a transit when the planet goes in front of its star. And what that's going to do is it's going to make the brightness of the star get dimmer. And then all you need to do is measure the amount of time that it takes for it to get to its normal brightness again until it starts to get dim again. And then that would be the time it took for that planet to go around its star. Okay, there was another method by using the Doppler effect. And by looking at the spectrum of light given off by the star is also orbiting. So it's not just that the star stays put and the planet goes around it. They're actually in orbit around each other, around their common center of mass in between the two. So that star is going to wobble just a little bit, and as it wobbles, some of the light sometimes will be coming towards Earth and sometimes away from the Earth, and it's going to make that Doppler effect. And if you graph it, you can find the period of the wobble, and then that would be the period. It's the same period as the planet going around that particular star. Okay, the next thing is, how do you figure out the distance to the planet from the star? All you got to know, Kepler's laws. Okay, you don't have to do any calculations with the formula, but you should know that by using Kepler's third law, you can figure out the distance to that particular planet. And then, how do you figure out the mass of the planet? Okay, just remember center of mass. So you don't need to know actually how to calculate it. So just know that you use the center of mass in order to figure out the mass of the planet. Okay, then this one is pretty easy. So how do you measure the radius of the planet? So it's going to be the percent of the light that is blocked whenever that planet goes in front of its star. So let's say, just for the sake of argument, that it blocks 100% of the light given off by that star. What would the radius of that planet, what would it have had to have been? The radius of the star, because it completely blocked all the light. If it blocks 25% of the light, then the area of that planet must be 25% the area of the star. If it blocks 10% of the light, then the area of that planet must be 10% the area of the star. Density, let's not worry about this, okay? But you would just take the mass of the planet divided by the volume of the planet, and that tells you about the density of the planet. This one's pretty important, okay? You're going to attach a diffraction grating to your telescope, and you're going to look at the emission spectrum of the planet. And then you can separate that emission spectrum into the individual spectrums of all the different gases in the atmosphere. You can also figure out the temperature by looking for which color in the spectrum is the brightest, because that would correspond to the maximum wavelength, and then you can plug that into Ven's law to figure out the temperature of that planet. So here's the summary of all the different things that we can learn about a planet, and then how do we learn it. And then here is the stuff that we've learned so far. So we have cataloged over 4,000 planets so far. And of those planets that we've looked at, many are close to their star, meaning that most of them are, there's more small terrestrial planets than there are gas giants. Another thing is a lot of these gas giants are too close to their star. And because a Jovian planet has to be born outside the ice line. But we're finding some of these Jovian planets right up next to the star that it's in orbit around, inside the ice line. So we need to come up with an explanation for that. So what's that explanation? So we're going to call it planetary wandering or planetary migration. And so there's this video here that if you can find this video on the internet, it would be a good idea to watch the segment where it talks about how Jupiter moved throughout the solar system. So we're going to start with Jupiter forming 1/3 closer than it is today. Now it's still going to form outside the ice line. Okay, but you can divide the solar system up into 3 main regions, gravitationally speaking, so that you've got the sun in the middle. Okay, it's surrounded by this disk of material, and then you've got Jupiter out here. Okay, and then you've got another disk of material out here. So this stuff out here, that's eventually going to be where Jupiter and Saturn, Uranus and Neptune live. And then this part in here, that's going to be the part where Earth and Venus and Mars are going to be. But here you got Jupiter, and it's going to be gravitationally attracting this material. So the gravity of Jupiter is going to be pulling on this material. And so this material is wanting to rotate around the sun, and because of the gravity of Jupiter, it's going to slow down the rotation rate of this disk, but you can't get something for nothing. So if this slows down, Jupiter speeds up. And if Jupiter speeds up, it's going to want to change its orbit. It's going to want to go further out into the solar system. Now the problem, though, is this material right here. So this material, what it's doing is it's pulling on Jupiter. So it's pulling Jupiter this way, the same way that Jupiter is pulling on this disk over here. And so this is slowing down Jupiter the same way that Jupiter is slowing down this disk. So if Jupiter's speed is getting lower, that means it's going to want to go this way towards the sun. So it's got 2 forces acting on it. It's got the force because of its gravity on this disk, and it's got the force because of the gravity of this disk on itself. And at first, what's going to happen is this outer disk is going to win, and Jupiter is going to start moving towards the sun. And that's what would have happened, and Jupiter would have ended up pretty close to the sun if it wasn't for Saturn. So the planet Saturn comes along and it starts eating up this disk out here. And then without its gravitational interaction, Jupiter then begins to speed up and it starts moving that way. And so it and Saturn move further out into the solar system. And then also, same thing for Uranus and Neptune. So they also moved further out into the solar system. So this would make for a good essay question. And I will understand that this is pretty complex, but just try to get as many parts of this explanation into your essay question as you can. Okay, that's it. So study up for this exam, and then I'll see you in class for it, and hope that you do really well on it. So until then, bye.